For anybody who is already here, I'm just going to share the bit.ly link in the chat box. So if you want to, you can go to the Google Drive and start downloading the virtual machine. We're box, so if you can download VirtualBox as well, or you don't have it installed already, it's just virtualbox.org, and then you can load the VM into VirtualBox. But we'll give you a quick run through of how to do that too. If for some reason you just don't really feel like doing the workshop along with us, or you just want to watch and do it later, that's totally fine. These are going to be recorded, so you'll have access to the drive and stuff. You can always do it on your own afterwards. And we've shared answer keys essentially for all of the samples we're looking at, so you kind of have some guideposts as you're going through it.
Yeah, and I think there's definitely more on the drive than what we can cover in this time. You guys have practice stuff. Astrid, well, we're gonna send a link in the chat. Here, let me.
Yeah, it's just should be up there now. Bit.ly 3R8UKLA.
Yeah.
Okay, cool. It's 12:05. Do you want to get started?
Yes.
Sounds good. Thanks for coming, everyone. This is exciting. It's a little bittersweet that we can't be all together in real life, but I mean, this is the next best thing, especially considering we can have like 1,400 people at this conference. It's incredible. So a little bit about us very quickly. My name's Kristina. I'm a senior security intelligence engineer at Lookout, which is just a fancy way of saying I'm a malware researcher. And before that, I came into malware from application security. I was at a company called Shopify and mostly worked on basically security engineering for the Android application that they made. I have a few places you can reach me on the internet if you have any questions or want to follow up on anything. And Kristin, I'll pass it over to you.
Yeah, and I am also out. I'm on our threat intelligence team where we reverse mobile applications, but primarily with the focus of finding a little bit more background context around the campaigns that they're used in, the actors who might be using them. Typically, we tend to focus on like nation-state surveillanceware and surveillance campaigns targeting either activist minorities, government targets, whatever. And so I've been here for almost 3 years, and I am the non-technical and somehow got into this from being a history and German studies major. So anyone can kind of get into it. It was a major career pivot, I guess, but had really good mentors along the way. And so I really like what I do now. So it's fun to be in it.
Yeah, I totally echo that. What we do it's a fun challenge, but there's always something exciting. I feel like no day is ever the same as the day before.
Yeah. So what we're going to be doing today for y'all is a mix of, day in the life of what we do plus how to do it. So we're going to first give you the links again that are in the chat for setting up the environment, and the links will always be in the bottom corner of all the slides. So if you're late to it or if you don't see it in the chat, it'll be down there for you to download. We're going to get into Android malware basics, information about, why mobile malware, why focus on that. Cover some useful tools. So if you're setting up an environment to analyze malware, what you want to be using, how to find it, what are some key indicators something could be malware. And then we have 4 samples for you guys that we're going to work through, I guess, as much as we can in the allotted time. So we're going to start off with Easylogger, which Kristina is going to focus on. I think she just created coverage for recently. We have Silverhawk, which is interesting because that was used in a multi-year Syrian surveillance campaign. Anubis is a banking Trojan with some surveillance capabilities, and Spywaller is also kind of surveillance. So we'll explain more about what those mean, but that's kind of the agenda for today. Cool, so setting it up. Username and password. Forgot that thing. That's important. So you can see in the bottom corner, it'll be there the whole time. But if you don't have VirtualBox installed on your computer, you can download it right now at virtualbox.org. And then the custom virtual machine that we've created for you guys is at that bit.ly link. Both those links are in the chat right here. And as Apurva pointed out, it's the .oba file in the Google Drive. So download it, the username, root, password, day of security. I just threw those in the chat as well for you guys. So download it now if you can while you're following along, because it might take a while. If you wanted to download it to follow along, because towards the end we're going to actually be going into the tools and reversing. But if not, get it at a later time. And next slide. Okay. Sweet. So kind of getting into like what about mobile malware and mobile malware basics. So I think, at least before I got into this industry, when I thought of malware, I was like, oh yeah, like the bad emails you click on, or like your computer's infected, something like that. And then it turns out your smartphones now, since they are basically mini computers that you hold in your hand at all time, like they also are capable of getting infected to the same extent that your computers are. But a lot of people, I don't think, realize that. And so it is a really niche area to focus on. But if you think about it, I think there's also a lot of logic as to why you should focus on it. The most recent Gartner study said that the sale of smartphones globally is going to hit 1.5 billion units in 2021, which is over an 11% increase from last year. And that breakdown, as of January 2021, almost 72% of the world's phones are Android, 27% are iOS, and then you have a small other subset there. I focus specifically on Android malware, as does Kristina, and as you can see, that's almost 3/4 of the world population uses Android. And so it is definitely of much, I guess, and it's weird because I have an iPhone, but there's a lot more people that have Android than iOS, and there's a lot of malware that goes on it. So, okay, that'll ensure you have a job, and there's going to be a lot of interesting stuff to look at. And if you go to the next slide, the other reason why it's interesting is because, like we mentioned, it's basically a smart computer, but you have the perfect spy platform in your pocket. Because as phones have developed, you have your contacts, you have your camera, you have your GPS location, your calls, your messages, like sensitive pictures, the apps, your Spotify, so they know what, your music preferences, any files you might upload to your device. People have work files on there as well. You can read PDFs, Google Docs, Word files, stuff like that, your browser history. So if I wanted to know more about someone, all I have to do is look at their phone. I think a lot of people sometimes also guard their phones really closely, and it makes perfect sense because it's a very private area. But the interesting thing about mobile devices as well is, I guess we aren't used to people maybe trying to gain access to them, or so you're very trusting of what appears on your phone, which is why there's also been a really huge rise in mobile phishing lately. Because if you get a text message saying, oh, hey, your UPS delivery has been delayed, click here to track it, you kind of tend to trust these things. And so it's just a different platform where people, I think, are less wary of scams or malicious things happening on it than on their actual computer. So it definitely sets the stage for a wide variety of malware or unwanted applications to exist and infect your device. So if you go to the next slide, how you typically would get infected on your device is you might get mobile phishing. So you might get a text or an email you read on your phone or something, or a social media post sent to you. Like if you got a text message saying, hey, download this app so we can chat on it more securely, or, the classic, hey, download this to chat to singles near you or whatever. So you download the application on your device. You either grant it a ton of permissions, or you click through and say yes, accept, because a lot of the times you don't really care what it's doing. And that malicious application will, on your phone, elevate the privileges it has. It can either itself be fully malicious, or it might be benign, but reach out and download a second stage application and install it on your device. It might be a remote access Trojan. And if it's on your device, an attacker might be able to execute commands on your device. Yeah, it elevates privileges and then can spy on your device, or it can possibly steal sensitive information. If you want to go to the next slide, so that's basically the kind of standard workflow of how your device might get infected for a malicious application. And then going into the different types of mobile malware. So this is what we're going to get into later, and we have several examples kind of in different categories here. But there's riskware, adware, you have Trojans. So adware could install on your device and just have super annoying pop-ups like you might see on an infected computer. Or banking Trojans with goals to steal banking credentials and logins. And then you have spyware and surveillanceware, which surveillanceware is kind of, I think, a lookout terminology, but they kind of mean the same thing. They're very invasive and will tend to steal your pictures, your location, your contacts, anything like that. But the difference of kind of how we differentiate it between the two is surveillanceware tends to be more niche targeted campaigns, like, you know, if you have a government targeting 10 dissidents, like with a custom type of malware, that would be surveillanceware. But spyware is a broader category, which can be comprised of things that you might have heard of, such as like spouseware, or even child tracking apps that don't necessarily let the child know they're being monitored. But what was really interesting is Malwarebytes puts out a state of malware report every year, and their most recent 2020 report showed a spyware increase of over 1,000% in 2020, which there were several articles that came out about this last year, but the increase in stalkerware, or essentially spouseware, like these, you know, what a spouse might put on their other spouse's device if they don't trust them to spy on them, that along with rates of like domestic abuse drastically increased during the COVID lockdown. And so along with spyware installs on devices during COVID lockdowns. That is just one genre that we do a lot of tracking of. And then we did also see a large increase of in 2020. And so next slide, if you can do that, Kristina, or we're texting each other to make sure this works. And so here's an example also, because mobile malware is really easy to access. This is even kind of almost an expensive purchase, but you know, you can buy a lifetime license of this SpyNote mobile malware for $500, or you can get 10 devices for $4,000. But some are as simple as like $30 a month or $20 a month. Literally, if you Google mobile surveillance, or you know, Android spy or something, they'll all come up, and they have like tutorials on how to install it, how to use it, the capabilities. They market it like a valid product, even though it is pretty nefarious. So if you want to go to the next slide. Okay, so useful tools, and I'll let Kristina take this over.
Hey, sorry, for some reason I can't hear anything, even though it says my headphones are fine and my audio is fine. But I'm going to cover what tools we have on the virtual machine and what we're going to be working with today. So if for any reason you can't hear me or something wonky happens, just let me know in the chat and I'll try to fix it. So the virtual machine that you have that is in the link that we talked about earlier down in the bottom right-hand corner here has all the tools we're going to be talking about here, but we're including them so that you kind of have a sense of what they do, why we even bother using them, how to run them, that kind of thing. Especially for those of you who might want to work through this later, the steps are still here. So when you are analyzing malware, there are a few really important tools that you need. For us, a lot of the time we're using the command line because it's an easier way to kind of interact quickly with some samples. One example of that is using a function called strings, which basically pulls out any little series of characters or text from a potentially malicious file so that you can kind of search through it quickly and see if there's anything interesting in there. We'll look at an example of that. Another great tool that you need is a disassembly tool. And this essentially takes what would be an executable file and converts it into something that you can kind of make sense of. It's basically showing you at sort of a low level what's happening, what instructions are being passed to the computer. And we'll look at the difference between that and another tool called a Decompilation Tool. Similarly-ish to a disassembly tool, this is taking a binary or an executable file and turning it into something that we as researchers can read. We're not able to look at bytecode and make sense of it. If you are, that is a superhuman power, and I would love to have that. But we have to basically convert our executable to something that we can look at, whether it's a higher level source code or programming language, or something that's a bit low level and is actually assembly and like kind of these processor instructions. So we'll look at both of those tools. Something that's also handy to have is an emulator or a device. Now, something I'm asked a lot is whether an emulator is okay to use for analysis. I think the majority of the time, yes, especially if you're just getting into research and you're kind of just doing this as a side project. You don't necessarily need to go out and buy a device. There are samples that use anti-emulator detection. So they basically try and hide all their malicious functionality if they can sense that their application's running on an emulator. And so that can make it more difficult if you're dealing with slightly more sophisticated samples to actually get the malicious activity to show on your phone or your device. It could also be a tablet. Now, when I started doing this, I started basically just as an independent researcher, kind of teaching myself how this all works. And I was able to find just a really old tablet for like $50 Canadian, so like, I don't know, 35 US. And I was able to use that to run a lot of the applications I wanted to test. So I was able to run in a real live environment and not worry about any kind of anti-emulator detection or emulator evasion techniques that might be introduced. So that's always an option too. But emulators are typically fine, especially if you're just kind of starting out with this. Another important tool is some kind of code editor. This can be helpful if you want to quickly script something that will help you automate a process. Let's say you're going through a whole bunch of different files looking for strings or something, and you want to create some kind of script that lets you do that quickly. That can be very handy. It's also helpful for looking at various files that might exist within the application. You don't necessarily want to open up you know, a decompilation tool just to kind of look at something really quickly. So being able to just open something in a code editor and look at the source code is pretty handy. And then Android Debug Bridge. This we won't be working with today, but this is helpful if you want to interact with an emulator or a device. It basically lets you kind of like tap into the device that's connected to your computer and look through the file system and see which applications are installed and all of that good stuff. So we have some slides on how you actually set that up and how you would interact with it in kind of like a basic level. But we won't be looking at that today just because we don't have enough time to go through setting it up and all that kind of stuff. But it's a very handy tool to have for analyzing any kind of sample. And then finally is a network traffic analyzer. We're going to be using a tool called Wireshark. And it's really important to analyze network traffic because this can give you an idea of what kind of communication is happening between a potentially malicious sample and, you know, the command and control server they're trying to reach. Sometimes in the code, it's maybe not necessarily obvious that, say, a malicious sample has exfiltrated somebody's SMS messages. And a lot of the times on more sophisticated samples, you'll have some kind of obfuscation or, you know, an attempt to hide the malicious functionality. And so it's good to be able to actually see, okay, what is the conversation happening between this device and that particular server? What is being shared? Am I able to see it? And if it's not encrypted traffic, then you're able to see it quite easily. And we'll look at some samples of that today. Come on, there we go. So I talked about disassembling versus decompiling, and this is an example of the two. So as I said, decompiling is taking a binary file and putting it into a higher level output or like a higher level programming language. So we're going to be looking at our executable file within our APK and basically spitting out something that looks like a really good approximation of Java source code. And we'll see on the left-hand side here, this assembler code. If you are not familiar with assembly, then this can be a lot more difficult to interpret. And as you can see here, one of these is much longer than the other. So the assembler is essentially doing this exact same operation, this modulus 2 operation, and the pseudocode does it in a single line, and the assembler code does it in, I don't know how many lines are there, like 15 or something like that. So having a tool that actually spits out this pretty good like approximation of what the script would have, or the application would have looked like before it was compiled and actually made into the application is very handy for us. And if you want to learn more about this, Hexrays, they create the IDA Pro program. They have a really good full description of decompilers and disassemblers. It's pretty interesting if you're interested in that. So the first tool that I'm going to talk about is Apk Tool. And again, these are all on the VM, and we'll look at them kind of like in person, so to speak. Apk is really handy. All these tools we're talking about are free. And this is both a decoder and a decompiler. So it takes your APK file and it basically converts the executable, the text file, that's the file type of the executable that's being used, and it makes it into this kind of intermediary language called Smalley. So it's not quite Java and it's not quite assembly. It's easier to read, but not as nice to read as Java would be. But it gives you something that we as humans that can't read byte, like machine language or bytecode or any of that can actually make sense of. And then the other thing it does, which is really handy, is it actually takes all of your resource files. So any assets or files that might be describing what kind of layout you would have on the application, what the different views would look like. It makes all of that readable as well, and that's where the decoding comes in. And so if you're using Apk Tool on an application, you can get back the assets, the pictures, any kind of like audio files, any of that stuff that was bundled with the application. You can look at various XML files that are containing all of the strings that might not be hard-coded into the application. And that's really handy for kind of getting a first look at what's happening with the application. It also gives you back a readable version of what's called a manifest file, the Android manifest file. And this is where you have the permissions that are defined in the application and various classes that will act as receivers and services to do things like, say monitoring whether the device is receiving SMS messages, that kind of stuff. So the manifest also gives you a very good overview of what's happening in the application, and we'll take a look at that in a second. If you want to install Apk Tool anywhere, other than where you have it on the VM, these are the instructions to get it, and we'll walk through using it in a little bit. So another decompiler that is very handy is Jadex. Again, free. This guy is quite different from Apk Tool because it actually gives you a nice GUI interface to be able to actually view all of the source code that's been decompiled. So you get what basically looks like this screen here in the screenshot. And it will just take an APK file. You can also pass it a DEX or a jar or a bunch of different file types. We'll be passing it an APK. And it will show you what the code looks like, basically as like a pseudo Java code. And again, so it's showing you this approximation of Java, what the source code would look like before it was compiled. That's why it's being called a decompiler. And where Apk Tool just showed you the smally, we'll take a look at what that looks like. The Java is it's a lot nicer on your eyes, especially if you're used to looking at Java from any other work that you've ever done. It also decodes resource files and the manifest file, and so it's kind of like a one-stop shop for decompiling your APK. Now a disassembler, again, creating that sort of like the list of I guess like processor instructions that we saw. An example of that is Ghidra, and this is a free alternative to a very popular tool called IDA or IDA Pro. We have included this, although we're not likely to get to actual native code reversing, but Ghidra is a fantastic tool for looking at any kind of native code that might exist in an application. And so native code is basically code that's been written in C or C++. It's allowed to interact with Java objects, and this is facilitated through something called the JNI, or the Java Native Interface, that kind of acts like a bridge between the Java code and the C or C++. But when you reverse engineer the C and C++ executable, you're getting this assembly language. You're getting basically this disassembler output that we saw in one of the earlier slides. And so Ghidra is necessary for that. You can't pass an executable that was written in C or C++ to something like we just looked at with Jadex, because it just won't give you the proper output. It really is just working with those Java files. And again, this is on the other thing. Oh, and something important I should note as well is if you look down on the bottom right-hand side, there's a link to a tool called Remagine, and this is a really cool service tool that's online. You can create a username, and it actually has Ghidra built into the application, so you can actually create a team with your friends, and a bunch of you can work together, look at the exact same sample, same binary that you want to reverse engineer, and collaborate on projects. So we have a link there that you're able to sign up, and it's a very cool way to make basically reverse engineering more of like a pair programming exercise. The next tool is Wireshark, and this is what I talked about as a network traffic analyzer or protocol analyzer. And it looks just like the screenshot here. You basically pass in something called a PCAP, which is just a packet capture of the discussions between the device and the server. And you can go through and see which different protocols were being used. In this example, you can see there's an HTTP protocol being used, and they're passing some kind of information from presumably the device or like the host to a particular server. And what's interesting with analyzing these PCAPs is sometimes you can even actually get the files that were being sent to the command and control server. And so we have one example. One of our PCAPs will actually allow you to look at the HTTP protocol discussion that's happening and basically export the files that were being sent from the malicious application to the server. So it's again, really handy for being able to see what kind of discussions are happening between the device and a potentially malicious command and control server, and seeing what was actually sent along to them too. And now Android Debug Bridge, this is how you set it up if you're running a Linux machine. We are using Linux for the virtual machine. It's a very lightweight implementation of Kali, which is a kind of well-known like security flavor, I guess, of the Linux operating system. So we just sort of stripped it down a bit to just have the tools that we need. And again, ADB is great. It interacts with your devices and your emulators as well. It gives you a shell. You can see what the file system looks like. You can see which files have been added. If you're using an emulator, you get root access. If you're using a device, you'll have to actually root the device to be able to access some of the file directories that are restricted to kind of those escalated privileges. But you can also actually run a log of the device and see what's happening as your malicious application is running. These are some basic commands. So this is basically how you interact with ADB. It's pretty simple. You can actually look up all of these commands just by doing a simple Google search for like Android Debug Bridge commands, and it'll show you all these and a whole bunch more. But if you want to see what devices are on your computer that have been connected that you can actually interact with, you can run ADB devices. And if you want to get a shell for the device, if you only have one, you don't need to pass that S flag. That's just specifying what the ID would be of your device. You can just write ADB shell, and it'll give you access to actually being inside your device and interacting with it through a shell. And an important caveat is that if you're not using an emulator, if you're using an actual physical device, you'll need to have your device in developer mode, and you'll need to turn on USB debugging so that your computer can actually recognize it. And these are just the steps to do that. It's a little bit like tapping build number 7 times for whatever reason. It's pretty standard across multiple devices, and this should work for, I think, most devices that we've ever kind of had to do this for. Okay, and now that we've talked about tools, we're going to kind of look at how exactly those would be used. So something that's important to note about Android applications, and something that I didn't know coming into this until I started reversing applications, not just building them and acting as a software engineer, is that APKs are basically just like zipped directories. So you can actually run unzip on an APK, and it will give you files. The way that Android applications are actually packaged is you have your Java code, and then this gets compiled and it becomes this executable file, this DEX bytecode. Classes.dex is usually what it's called. Sometimes you can have multiple DEX files. If you have a particularly large application, you can have classes 1, 2, or I guess it's just classes.dex, classes2.dex, etc. This is also a way that a lot of malicious applications hide their malicious functionality. They stick them into like classes 4, 5, etc. So it's not all just in that kind of like top level classes.dex file. And then it also creates this manifest file, as we've talked about, that sort of outlines the different permissions that are going to be asked of the device and various classes that will be interacting with certain capabilities that the device has, for example, whether it wants to receive SMS messages or send them and all that kind of thing. And then you have assets and resources. Again, these are things like images or media files, non-hard-coded strings that might exist as a particular resource that's pulled in from a separate strings file and not just like typed directly into the source code. And all this is bundled together, and you get your Android package with the file type APK. And now if you're reversing this, as I said, it's really just a zip directory. So you can run just unzip against .apk files, and you will get your classes.dex file. You'll get a manifest file that's not readable. It's not decoded, so you can't actually make sense of it. Resource files, same thing. None of that's going to be human readable. The classes.dex file is handy because you can still run certain operations against it. Like you can run strings against it, for example, and pull out like what I talked about before, the various like series of characters that might give you something interesting, like hard-coded URLs and that sort of stuff. But if you actually want to look at the various files that are packaged together in a way that's human readable and not bytecode, then we need to use something like Apk Tool. And or in this case, you can also use Jadex, as we said. So if you got your APK, you can run Apk Tool against it, and that will give you your smally classes, again, that intermediary language between the bytecode and not quite assembly, but not quite Java. It's somewhere in between. You've got your manifest file that's decoded that you can actually view, all your assets, any kind of like metadata, libraries, and resources. And then from there, you can kind of just like work with those files, or if you wanted to, you could also use a couple of other tools that we're not necessarily going to interact with as much, but dex2jar is something that will take your classes.dex file and turn it into a compiled Java class file that you could then pass into other applications. Jadex can take the jar file, or you can just pass it the APK if you want to do that. And then the Jadex can also export these class files. Another tool that can do this is JDGUI, which is also free, and that would take in the jar file and give you something kind of like what we'll see with Jadex, this sort of approximation of Java source code. All right, and now Kristin's going to talk about hunting for malware.
Yeah, so there's kind of a few different places where you could. So internally, because we work at a security company, I think we kind of have it a little bit easier just because in general, Lookout focuses on mobile security. And so we do ingest a lot of malicious applications, you know, malicious and benign alike. But we have over 120 million in our corpus and bring in around 90,000 a day. But obviously with numbers that large, you do have to really work on, you can't scan that manually every day. Like, okay, what are some good ways to narrow down? Is anything like, you know, possibly malicious in there? So Android applications list like various permissions that they use. So sometimes searching through a variety of combinations of like permissions plus how popular the applications seem to be, or for example, the permissions plus what the application is pretending to be. If I saw, for example, an app with the title calculator, but then I saw it had the permission and capability to make phone calls and read your text messages, I would say, that's pretty odd that a calculator application wants to make phone calls. And so I might dig into that a little bit further. So that's kind of like our own internal database. But then also externally, there's a lot of good public sources, even like, you know, beginner malware interested people can go look. So GitHub, there's several repositories people have put together that are known APT samples, advanced persistent threats, and malware related to those activities. Twitter feeds, a lot of the leads I get, sometimes I just follow different accounts that tweet out malware hashes when they find something and then dig into it a bit further. You know, Virus Total, VX Intel. VX Intel is cool because it has tons of malware you can register and just like kind of dig through all of it. Hybrid analysis is free. There's Malware Bazaar. And then also if you're ever just curious and want to practice pulling stuff apart, you know, third-party app stores like Cafe Bazaar or APK Pure, stuff like that. It might not be malicious, but if you just wanted to, you know, look at applications, that's where you can get those from there. And if you go to the next slide, Kristina, if you can hear me, I don't think she can. Okay, so next slide, texted her. Once you're looking on those sites or once you found something, other hints that might give away if it is malicious or not. And we're going to look into later how to see this traffic, but does it have lots of useless packages, or are the naming conventions weird? Is something pretending to be like Google Updater Plus or, you know, WhatsApp, you know, Updater instead of actually just being an actual update? If once you're in the code, is it hiding its icon? Does it have a lot of DEX classes? You know, again, permissions. And then hints of you're looking at malware that someone else might have already found something in a related family. You can look at the domains or IP addresses it's communicating to. Is it communicating to some domain that we already know to be bad? Are there any unique strings that might give a hint at, you know, one developer being behind it that we already know of? Or sometimes the way an application is signed is that signature tied to any other malicious applications. So if you go next, let's see. Oh, did we skip the term slide? Whatever. Okay, so sample one. I don't think Kristina can hear me, but yeah. So, and
okay, yeah. Hi. We're communicating about next slide to make this work. Okay, so we're at the end of going through the slides. Now we're going to actually look at some real live malware samples. A couple things I want to note that's pretty important for what we're going to be looking at. Two things. The first is that these are actual malware samples. Please don't run them on a personal device. If you do want to test them, please limit that to an emulator or a device that is specifically part of your collection for just malware samples or testing or research, that kind of thing. The second point that I want to make is that some of these samples can contain hard-coded credentials. So for example, there might be a username and password to an FTP server. And although it's kind of crazy that that exists, it's also illegal for those of us in certain countries. I know North America, it's illegal. I'm not sure about other countries specifically, but I would just err on the side of caution and not do it. It's illegal for you to actually access those servers using the hard-coded username and password. So please don't do that. Again, you might come across that sort of stuff during your research, and it's always a little bit shocking that someone would hard code in their password, but it does happen, and you can get into a lot of trouble if you actually go looking through that server. So just want to throw that out there. Don't want anybody to get in trouble during their research. And now we're going to hop into the virtual machine and take a look at the first sample. So as Kristin was saying, the first sample that we're going to look at is Easylogger. This is an interesting sample because it's actually commercial. So you could find this application for sale on the internet. It positions itself as a tool. So let's say that you want to make sure that your loved one is safe, and by maintaining their safety, you want to be able to like check their SMS messages and like where they're located and all that kind of stuff. That's how they position it. They're like a safety app that just happens to collect all the information on the device that it's installed in. Now, this is sort of a bit of a tricky area to navigate because most of the time these tools are considered stalkerware. They're often used in domestic abuse cases to track partners and spouses and to keep an eye on what they're doing. And a lot of these applications can hide their application. Or hide the application icon. And Kristin talked about that earlier as an important indicator of compromise for a lot of situations where you have an app that suddenly, shows up on your device and then suddenly the icon's disappeared. So we're going to take a look at this guy. We're going to use Jadex and Wireshark to look at the network traffic as well as the reversed application and kind of get a sense of what the source code might look like. And while we're working through this, I want to kind of have you keep in mind some questions. So we're going to figure out where they have 3 invasive capabilities. There's way more than that, but we're going to start with 3. And where those are being used in the code, what kind of data this app is trying to collect, and then what the command and control server is. And so we're going to hop into this. I'm going to close my slides. And again, if you're not working through this with us right now, we have answers on the virtual machine that you can take a look at. Okay, and I'm actually going to refresh my Hopin connection because I'm hoping that I'll be able to hear Kristin if I do that. And I figure this is the perfect time to do it because we're not still on the slides. So just give me 1 second.
In the meantime, if you are downloading VM, hopefully it took a while. It's several gigs, but it's there, and if you feel like following along, go for it. If not, you're dealing with once you pull it up.
Okay.
Oh, perfect. Okay. Cool.
Okay, I'm going to share my screen again. Okay, so there we go. Perfect. All right, I'm going to drag over my virtual machine. And I don't need this. This a bit bigger. If you're working with your virtual machine and it looks super teeny tiny, you can do a few things. You can say auto resize guest display and adjust window size and play around with that. Or you can also go to scale factor, and this will do this more. Increase, there we go, the size of your virtual machine. Okay, so we're going to log in as root, and the password again is day of security. And then it'll bring you into your desktop. And so we've got all of your tools and everything you need saved here on the desktop just to make it easy to interact with. And if you go into this malware directory, you will see an alert that says you're using the root account and may harm your system, but that's okay because we are working with malware. And this is a virtual machine, so we're pretty safe. And the first sample we're going to look at is Easylogger. So we're going to go into that directory. There we go. And so we have an APK here. Now, we can pass this directly to Jadex, but we can also run Apk Tool on this. And I'm going to show you what it looks like when we do that. So we're going to go into our terminal down there and hop over to Desktop, Malware, Easylogger. And there's our APK file. So in order to actually run Apk Tool against this, all you have to do is type Apk Tool D and then you type in the package. And it's going to do its magic and decode and decompile the application. Sometimes it can take a couple minutes depending on how large a file we might have. We have a new directory called the same file name as our APK, and if we hop in there, we can see basically what we looked at on the slides. So we've got our Android manifest file, we've got this sort of just output YAML file that just tells us some information about the process the APK tool went through, our assets, the original, which would just be like the original executable files, the resources, which is res, Smalley, which if we go into in a second, you'll see what Smalley looks like. And then unknown is just sometimes stuff that like it couldn't quite make out with the decompilation process. You rarely have to worry about that, but we'll see if there's anything actually in there. Sometimes it's just, okay, so it's just information about the build, that basically the way that the Java application was compiled. Okay, so let's go back into Smalley and I'll show you what I mean with this intermediary language. So let's go into com, and then there's an A, name, A. Doesn't really matter what we grab right now. We just want to kind of look at what the source looks like. And let's go into, I don't know, bb.smalley. So I'm going to use Vim as my code editor to take a look. And so this is what Smalley looks like. You know, you're not looking at bytecode, you're not looking at assembly. You can kind of get an idea of what's going on here. There's a method being created. You've got another method here, but it's, you know, it's not quite as pleasant as looking at Java source code. So if we go back, a whole bunch to, gosh, we're still there, our Easylogger directory, we can just go right into the APK and open that with Jadex. So let's go to our desktop and tools. And then in here, we'll have a directory called Jadex. And then within Jadex, we're going to hop over to build and then bin. Is that right? Might be wrong. Oh, build Jadex and then bin. And if you look at what files exist there, then you're going to see all of these executables. The green just means that you can actually run them. So we're going to run Jadex GUI. You can also run Jadex in the command line. I've not really done that very often. I just sort of like that you have a graphical user interface for it. And so in order to actually run the tool, this is all you type. This is just showing that you want to actually execute the file. Hit enter. And it'll take a second, but we will get our Jadex GUI. So we're going to open this Easylogger file. Just find the APK and say open file. And there we have it. So now we have our APK decompiled into its various components. We've got resources that are in here that you can look through. Here's our Android manifest, which we've talked about, the assets, the original classes.dex file. If, you know, for some reason you wanted to look at that, it does have uses, and we'll look at that when finding the C2, but we're going to stick with the decompiled source and then various resources and stuff here. So let's look at the manifest file first, and I'll show you what I mean about this being a good place to start when looking at an application to kind of get an idea of what's happening sort of under the hood. So if we go to the top, you'll see a whole bunch of permissions that are declared, and this is what the application is going to attempt to ask for permission to access. Some of these are not particularly concerning, so some of them are, And this is a good indicator of whether the sample you're looking at could be malicious. So for example, let's say you are installing a calculator application and you decide that you're either going to look at the source, or you're just going to kind of keep a keen eye on what permissions it's asking for when you've installed it on your device. If it's asking to read your call logs, that might be a little bit of an indicator something sketchy is happening, because why would a calculator need your call logs? And as we saw in some of the slides, a lot of the times an indicator of a malicious application is something that uses a very generic name, like com.android.calculator, when it's really something like spyware or surveillanceware that's trying to collect a little bit too much information about you. So here we can see a whole bunch of permissions: read SMS, read call log, read phone state, receive SMS. The dangerous ones, and if you look at the answer text file for this sample, I've linked to the Android page that kind of goes through all the various permissions and what they mean. But the dangerous ones mean that they typically require explicit user interaction, because there's something that could compromise your security or your privacy. So for example, reading call logs or reading SMS or accessing find location. Accessing find location means that it's able to get your location to a more kind of like specific point. You're not just kind of getting like, oh, so-and-so is in, say, Toronto. It's like they kind of have an idea of the general area within Toronto where you are. So it's a lot more targeted. And so that's considered a dangerous permission. And you see that a lot in surveillanceware, because if they want to track where you are, that's how you do it. We also see here read external storage, write external storage, get accounts. Oh, my phone thinks I'm talking to it. It heard me say Android or Google. Reading and writing external storage. This is a way that a lot of times applications are going to try and get things like photos, or sometimes they'll try and create log files based on what's happening on your device and store them in external storage, and then use that and exfiltrate from there. A lot of the times external storage doesn't necessarily require elevated permissions to access. So if you've given an application access to it through, say, just allowing the app to write or read from your, say, your SD card, then it kind of has free reign about what it can see. And a lot of malicious applications use your external storage to kind of like see what is on your device and what sort of sensitive information they could make use of. So going back to the questions, we want to find 3 capabilities that are invasive or potentially malicious. And so if we're looking through here, we've got more than 3. I would say that read SMS, accessing find location, and then reading and writing external storage, those could be particularly dangerous or potentially dangerous. And so you could grab any of these that would fit that sort of dangerous category and say that those would be invasive. And so now we're going to see where they live. If we scroll down, we can figure out where the application is starting. So what class is being called when we actually launch this application. And we can do that by looking at these 2 intents. So we have this main and launcher. And if we look at this activity tag and we look at Android name, this is going to show us which class in our application is going to be launched when we actually load the application. So app.easylogger.splash. So we can start there and look through and kind of like follow the process of the application and see which classes it calls from there. And we can also continue looking at the manifest for where other receivers or services might exist. So here's a receiver for boot completed, which is basically saying like, has your phone finished loading? And then you can see that there is actually a class called boot completed receiver. So, very to the point. And it's looking at these particular intents. Shutdown receivers, same kind of deal. Connectivity change receiver, this is typically looking for whether you've changed your network state, if you're moving from Wi-Fi to say like your network data traffic. And you can kind of look through all of these various receivers and services for the various permissions that we just talked about. So location tracking services, probably a good indication that access find location might be used there. We'll keep an eye on that guy. And what else do we have? A lot of these are just based on databases, Firebase is like a database service that a lot of applications use. Okay, so let's go into our various class files over here and figure out what's going on in some of these more interesting classes. So we know from looking at the launcher, as well as this location tracking service, that the path to get there is app.easylogger.services. Whatever the class is. So we go over here and we see app.easylogger. We can open that up. And then we have a whole bunch of classes. So here's the splash activity that is the first thing that's called when we launch our application. And we can see, as we talked about, a pretty good approximation of what the Java source code would look like before it was compiled. This really does look like Java, and it's not always going to be perfectly decompiled. Sometimes you might see that Jadex is giving you an error and it wasn't able to kind of finish the decompilation process, but it's a pretty good approximation. And so here we can see, okay, there's an interesting string for reading phone state, writing external storage. It looks like this is probably going to be triggered to ask the user for those permissions again. And we can kind of scroll through and see if we see any reference to some of the sketchier permissions that we had. Checking permissions. Here we go. Here's a hard-coded string message that's saying you need permissions to run, and it's asking you to go to your settings and give Easylogger all of your permissions, or access to all the permissions it wants. And so it's showing you that message. All right. And now something that's important to note, and that is quite handy for those of us who are malware researchers, are logging messages. A lot of the times logging messages take the form of this kind of method. So you have essentially just a method. It could be log. In this case, it's just A because they've tried to hide what the actual logging method would be. But it's just a very short kind of method call like this, followed by one string parameter and then a second string parameter, or whatever it's passing to actually be logged. Sometimes it can be a variable, like in this case. But usually a lot of hints about what's happening in the application exist in the logs. Sometimes you'll get malware authors that have logs that say, I don't know, send evil file to C2. I've seen something almost that on the nose. And so it's a good way of sort of getting a sense of what's happening in the application. Not every malware author suspects that you'll actually be reverse engineering their code. So they're not always that cautious with what they write.
Statements and misspellings. But to Kristina's point also,
yes,
when you look at the logging statements, if you ever are in a position where you have a database of malware to cross-reference, a database of apps to cross-reference, these strings in the logging statements sometimes can be very unique only to certain authors. So if you find a unique string and you see in our entire body of malware that string is only in 10 applications, it's very likely that they're all created by the same person and can help how much malware in that certain family actually exists.
Yeah, 100%. It's incredibly helpful. So we've been through this sort of launching activity, and really what it looks like it's doing is, as we can see from these logging messages, checking to see whether permissions have been set. So a lot of the times with this kind of stalkerware, this commercial surveillanceware, they're anticipating that somebody is installing it on a device, and so they're telling you, hey, you need to allow all these permissions so we can get all of your activities, or all of the activity that's happening on your device. So that's likely what this case is. So now let's go to something a little bit more interesting. Let's go look at that location service. Oh, actually, here's a class called hide app. Good indication it's probably trying to hide the app icon. So there's probably some interesting stuff in there too, but let's focus on that location tracking service. Okay, so here we go. We've gone into services, application watcher services, location tracking service. We click that guy. And we go in here. Here's another logging message, location tracking service. And we can see here again that it's checking to see whether you have access to this permission, this access find location. More logging messages about whether that is set up. And then you have some functionality around the actual logging of the location of the device. Sometimes you'll see malicious applications trying to use things like the accelerometer. Even sometimes that exists in location tracking, even though it doesn't quite make sense. In this case, you can see, you're getting what the accuracy is of a particular location that's being collected, longitude, latitude. Here's the accuracy, the speed of what is actually the change in location. Time. Okay, so here's another logging message we can look at, on location changed, called this. All right, so we found one of our answers. Where is the location tracking happening? Where is the get find location actually used? Here's one example in this location tracking service class. And if you keep going through it, you can see that it's basically just like a standard class, actually, that you would see in a lot of software projects to interact with a particular feature. It's just trying to see where the person is, where the device is specifically, and all the details around that, and then collect those details and presumably send them off to somebody. Okay, so that's one example. And now if we're looking through other things like, say, SMS messages, one of the ways we can actually find where that might exist is by going into search through that icon on the very top bar. Now, Jadex is pretty interesting because it lets you actually do a very specific search for whether you're looking for a class name or a method name or just anywhere in code. And we're going to use anywhere in code because we want to see any reference, whether it's logging or like a hard-coded string, to the SMS permission or just SMS in general. So we're going to say code, just type in SMS, and it'll bring you a whole bunch of options. So if we go down here, we see, here's again this hard-coded permission, read SMS, requires read SMS permission, all of this kind of stuff. Where does this exist? This exists in app.easylogger.b.m.a. Now, a lot of times malware authors will use this kind of obfuscation technique. It's called lexical obfuscation. And what that basically means is they're changing the class names or the method names into kind of like gobbledygook that doesn't actually make sense to you, as a way to make it a little bit more difficult for researchers to figure out what's going on. So instead of saying like a class that's called SMS, it might just be called B. And instead of a method that's called get SMS, it might just be called A, because that just makes it harder for us. You can still trace it, you can still figure out what's going on, but it's just not quite as on the nose as actually naming the class or the method what it should be. And so that's why this is like b.m.a. It's just not quite as pretty to look through. Okay, so let's hop into this class. And we see this is an example of Jadex not quite being able to fully decompile the file. So we see we get all these warnings, and then there's this area kind of commented out in green. So we can kind of see that there's reference to the SMS messaging there, but it's a little bit harder to figure out what the actual activity is happening. We know there's something to do with SMS in this class, so let's continue to take a look. Here we can see a JSON object being built with a whole bunch of different parameters, longitude, call date time, type, name, phone number, all that kind of stuff. Typically, when you have sensitive data that's being exfiltrated to another server, it's going to be through a JSON object like this. So this is a good indication that all of this information is being collected and it's about to be sent somewhere. So if we scroll up a bit more, we might see reference to SMS, or it could just be in that area that wasn't decompiled properly. Oop. Yeah, so let's go back to our search and see if there's anything else here that's been decompiled nicer, is not quite as messy to look through. We have a whole bunch of references to SMS. So there's the settings option. Let's go down here. Read call log. Double click that. There we go. This looks a bit better. It was actually decompiled properly. So we can see that there's a hard-coded string again, trying to look for these permissions. All of the permissions to do with, well, pretty much everything is here. Contacts, call logs, read SMS, all of this good stuff. So So we know that something is happening with getting our messages and having them exfiltrated. Let me just... It just got closed on me. Okay, so if we go into, let's say, this guy again. And we look through the various classes that are here. Let's also look for the external storage and reading and writing of storage. Again, we can do the same thing. Basically, anytime you say external, or we can just say storage, because sometimes there are actual methods that are just called get external storage, and like you're getting the path to where your external storage is. Storage concurrent access, okay. Here we go, here's an example. So get external storage directory, and then get absolute path. This is getting exactly what it says, your external storage path. So let's click that. And here we can see this is storing the path to our external storage. And so the application can try and access that. And this is in C again. And this is class G. Okay, interesting. So what if we want to find writing external storage? If we go back here, we search again. Oops. Right. You can also do case insensitive, which means you don't actually have to worry about whether you've capitalized it. Okay, so here we have where the permissions are being asked. Again, more permission checking. So we don't necessarily see like a method or something called write external storage. We know that there's something happening, but let's just kind of go through the various classes and see where it might actually exist. Okay. So as we said before, a lot of the times these obfuscated classes are meant to be used as a way to kind of like hide some of the malicious activities. So you can kind of guess that a lot of the bad stuff would be hiding in here. I mean, they've really not tried to hide that they're going to hide the app with this particular name, but in other areas they can. So we saw settings, and we saw that settings was talking about a whole bunch of different permissions. So we can look through here. Something happening in the background is a good indication there might be something malicious going on. Sometimes if you have the ability to, you can highlight your class name or the method name, and it'll highlight the other references to it in the file, which is also handy. Okay, let's go back here. So we see these package names. These are all to do with, these are like legitimate classes. These are google.android. These are like actual Android classes, google.firebase. Typically, those will be legitimate. So we're going to keep looking through the Easylogger package name. Oops, we don't want class, just want string. If we say, oopsies. Oh, right, external. Okay, login button, it's activity. Let's go back here. Okay, so it's asking for these permissions. Cool, so you know that in this class, it's once again checking that all of these exist, and it's trying to basically pull this up and make sure that it's actually been given the permissions that it needs. So if you go through the answer file and you look through the various permissions that are here, you'll see kind of like the path to get to each of the where these all exist. Receivers, Same kind of deal, outgoing calls, all of this stuff lives here. And you can basically pick any of the 3 options that you want for looking at where the these malicious
and the
samples
useful
might be.
thing about this family is they named their classes basically what they do. Sometimes you aren't so lucky with malware with weird obfuscated text or hidden names. So just click around in here and you should be able to find what you're looking for.
So the last thing I want to do before we hop over to the other sample is show you what I meant with this strings command on the classes.dex file. So if we go back to our desktop and malware and and we go into our Easylogger sample that's been run through Apk Tool. Here we have this, oh wait, wrong place. We didn't do that yet, ignore me. Okay, we're gonna unzip the APK and get the classes.dex file. So we're just gonna run unzip ap, for that guy.zip, APK. And just like you would any directory, everything is unzipped. And then we should have classes.dex. So you can see it right here. So even though we can't actually read this, if you go into classes.dex, it is bytecode, can't read it. So even though you have that, you can still run this strings command against it. So let's say you wanted to find your C2 and you don't want to look through all of those various files to do a string search or any of that kind of nonsense. You just want to quickly find out what sort of HTML formatted or URL formatted strings might exist in the application. What you can do is run strings, pass it classes.dex, and then this is a pipe. So this is basically taking the output of strings classes.dex and passing it to another function. And the other function is going to be grep, which is a search command. And we're just going to look for anything that starts with HTTP. Let's make it a little bit more specific. We're going to hit enter. Okay, so the thing that comes out, we get some kind of like gobbledygook here, but that doesn't necessarily matter. What we're actually passed back from that command are these strings that were hard-coded in the application that are formatted with, looking like they would be a URL. So from here, you can kind of guess that it's probably not going to be google.com. It's probably not going to be Google Analytics. But logger.mobi sounds suspiciously like Easylogger, and that could very well be where the command and control server is. And so if you go back into your application and you just search for this particular URL, you can see where this is being used and how it fits into the overall story with the application. Okay, so we're running out of time a little bit. I'm going to close this down, and we're going to look through Silverhawk.
I was going to say for Silver, I was going to say for Silverhawk, maybe we could approach it from the PCAP perspective first, and then get into Apk Tool. So along with the APKs we provided you, we've also provided network traffic samples in the form of PCAPs for all 3 families. And so you can either capture these on a device, or our automatic analysis of applications at Lookouts runs these applications on an emulator and has captured it for us here. So this Silverhawk PCAP right here. But like Kristina said, sometimes before I get into an application and spend a ton of time, like especially if it's like a little bit more complex, larger, obfuscated, if I'm like trying to figure out what it does, where it's communicating to, I might look at some network traffic, because sometimes if it runs correctly, it will automatically show me how the application, if it's surveillance, communicates with its command and control servers, like how it would format the data it's trying to exfiltrate and send it out. So if you open the PCAP with Wireshark, this is typically one of the first 2 things I'll do, either look at the strings to see if anything was hard-coded like in Easylogger was, or I'll look at this. So in Wireshark, it's open now, and off the bat, you can see that there is communication to a destination IP, which is 82.137.255.56. Ignore my dog barking. And then, I don't know what's going on there. Anyways, if you right click on the TCP in Wireshark and hit view TCP traffic, I think that's what it says. or follow TCP traffic.
Oh,
that's what it is.
Right click?
Yeah.
Follow.
TCP stream. Off the bat, that shows you instantly how it's communicating with that IP address. And it instantly looks pretty suspicious because it's sending out this thing called Hamza packet, but it's a little blurry on my end here, but it's sending out the device name and like what it's on. It's on an emulator, its location, its SIM number, if it's rooted, the date, I think, the Wi-Fi status. And if you scroll down a little bit, this huge chunk of information is being sent out to that IP address with data taken from our emulator. So imagine if it was it would be sending out essentially information about my phone out to this command and control address, which when you go in the code, we'll see is actually this 82.ip address. But one thing that also helps make reversing easier is when you have like a PCAP like this, and you can see how the data is transmitted, it gives you an idea of perhaps some key strings to look for in the code. So you can see some of the strings there are Hamza packet or Hamza delimiter stop. And this sample, once we open it up in Jadex, you'll see those are actually unique strings. And so if you go to the top of this PCAP, or it says command 30, I'm off the bat guessing there are going to be some strings called command inside the application that I can look at that will likely tell me what the command means and the type of data it's exfiltrating. And here command 30 is exfiltrating generic device information. But this is just a good off the bat way to use running network traffic to your advantage to like streamline the review process. So Kristina, if you want to open this up in Jadex as well. And this was one of the questions also that we had the answers to, but try and find the command and control infrastructure and guess how it would communicate out. And this sample of a packet capture clearly shows how the traffic communicates. Because I think also when I first started getting into reversing, it was kind of an abstract concept to me of how the data was sent. And so actually seeing the formatting of how it gets sent out really helped me contextualize the code I'm looking at with how it actually moves across. So it's in there's a Silverhawk. And just also for some context on Silverhawk, it's a family that several years ago, a former coworker and I presented at Black Hat, which was tied to the Syrian Electronic Army. And so basically surveillance tool used by pro-Assad hackers essentially to monitor dissidents. And so it was developed from an open source Android rat into their own custom tooling, which we named Silverhawk. So it's just a family we've been tracking for a few years, but samples are on VirusTotal. You can Google around. There's other research on it. The group is also known as APTC 27, I think. But so some things to look at in here. Obviously, you have the basic same layout as Easylogger, and you have the source code. But one thing that would be interesting to look into is, so Kristina initially in the first sample looked through the different source code classes. If you go into the resource folder, this is also where I like to poke for other goodies. So resources, res, if you click on that, you can scroll down. And typically if there's other stuff in here under raw or XML is sometimes where stuff is hidden. So here in this case, if you click on the raw folder, you get this Hamza VBS native library file, which I'm not sure if you double click it more, will you get the full title package for it?
No, so there are some limitations with Jadex that you don't necessarily have with some of the more like pricey, well, non-free applications, is it doesn't necessarily show you a very nice view of what this is. Even though it can kind of pull up something, it's going to give your Jadex a hard time. So like mine's kind of struggling to pull it up, and it's really just going to show you this kind of like gobbledygook.
Got it. Well, either way, as you start to explore this more, when we were talking back about the initial concept of unique strings, Hamza actually is a unique string for this malware family. And so if you click on the answer sheet, I've included some screenshots that I guess might not be available opening it in Jadex. But there actually was like remnants of a native library, an x86 image inside this raw folder, which under the information around the versions information of it, it had like some comments left behind from the developers and the original file name, which was WinAndro16XP, which then if you Google, You can find other open source research about people having tied that to desktop malware, to the same actors who were using this mobile malware. So you can see this was an interesting campaign because it was a multi-platform campaign. It was the same malicious actor spying on people, not just on their phones, but also on their computer as well. And so using the same infrastructure, and it gives you an idea of the different tooling that they're using. So that was one other example. And I guess, what were the other questions I had for this? So unique strings also, and find the invasive capabilities. I guess if you want to, off the bat, the last one we can quickly look at is, can you search for text in there? Is there a way in Jadex to show all the strings at once, or is it only through search?
Just through search, unless you want to just pull out strings through.
You can run strings. Yeah. So I'll let you guys, in the example when you download it, try and search for unique things. But in the last second, I actually wanted to see if we could pull in the one last sample from Anubis just to show you another cool malware command and control pattern, that, because I know we're running out of time. And if that's the case, Kristina, I don't think, oh yeah, you can just open the Anubis sample.
I note about Jadex, sometimes if you're trying to load a big file, like just then, trying to just open the search even was kind of slowing everything down. If you go back to your terminal where you actually triggered the executable file and just hit Control-C, that'll just shut it down and you can restart it. So just to kind of save you the pain of going through the.
Cool. So we'll open Anubis, and then Kristina will also open up the very bottom page of the Anubis answers, because that has some necessary screenshots in it. But just to kind of like get you a little bit more interested for hunting, and hopefully you guys download the VM. But in this Anubis sample, it's a banking Trojan, and it's made news for a while because it's ever evolving, developing. This one's a bit more obfuscated. The newest samples are way more obfuscated than this one. But this was an interesting family that I worked on when I first started Lookout several years ago that I thought was really cool because of how it communicated and found its command and control address. So it wasn't something that was just hard-coded in sometimes. So the easiest level you'll get is they just have it in the code. It's right there. Sometimes it will be combining two strings to make one domain, and then, that's how you find it. But this was actually really interesting because if you go to the class, Kristina, it's that jumble of letters, links, CFDDES, whatever, and then .ynjh, that one, .amx.c.
.c.
Okay, so just scroll down a little bit under, the C class right there. So you can see already this one is a little, it's not like super obfuscated, but the classes aren't always named like get GPS location. So if you scroll down in there, you'll see it's referencing opening a URL connection to twitter.com/inmailanton over there on the right in the middle of your screen. Open connection to that user, that Twitter user. This user is no longer active. But what this would do, and if you scroll down a little bit further, it would open a connection to go to that Twitter account. And do you see, it's a little blurry, at least on my screen, but it has these 0 delimiters. So it's looking for text that is between the two alligator mouths and says 0. And so if you go to the Google Doc and scroll to the very bottom, I've included screenshots of this because the account is now offline. But so it used to pull up this profile, Ann Millington, and if you zoom in, the Twitter bot had essentially tweeted out a base 64 encoded string in between these two delimiters, the two delimiters which are referenced in the code. And so what the malware would do then, it would get that string and then base 64 decode it, and that would actually be the command and control address. And that address turns out to be, it was activirung342675.services.ru. That was the command and control server. So Anubis was actually known for reaching out to Twitter, and there was a whole army of like Twitter bots that had to be taken offline because they were all tweeting out, malicious infrastructure, and then they pivoted away from the 0 delimiter to random Chinese characters, and then I'm not sure what they're doing now, but it was hard to kind of track them down. because that's not something you can very easily write heuristics for, because it's always changing also. And it was a commercial tool, so people could buy it, set it up however they wanted, set up their own domain, and use it as a banking Trojan. But I just thought that was kind of a clever way and really highlights the growing creativity in the malware field of how people are either working to hide their stuff or just make researchers' lives complicated. Because one of these families, or one of the Anubis samples, was actually interesting because they linked it to a security researcher's Twitter account just as like a joke on them. And, you know, they didn't actually have any malicious things on their account because it's really like a legitimate researcher. But you do often kind of see malicious actors realizing who the researchers are, following them, and leaving notes in their code for it. So that's kind of, you know, stuff for you to play with now. And we have that. And there's actually a fourth sample in the drive that I don't think made it to the VM, but you guys, the bit.ly links to the general drive. And that's a APK sample that has a native library in it, which if you wanted to open that in Ghidra and practice native library reversing, you can do that as well, because sometimes you'll have APKs bundled with their own native libraries that might contain command and control infrastructure as well. So feel free to dig into those. And yeah, there's answer sheets, and you can reach us on Twitter.
Mm-hmm. One thing I just want to show really quickly before we run out of time, got 3 minutes left. Something that's also really cool about Anubis, cool in the context of it, like kind of show what, or how innovative malware authors could be. So you might have heard about how using accessibility services on the device is a way to get around some of the permissions that you might not grant an application. For example, being able to show an overlay on the screen. If you look at the manifest file, along with a lot of this like really cool interaction with Twitter, you will actually see, and this is like notify the user that you're getting a phone call, you've got an SMS message. But if you can sneak in that permission there, you can also use it for ransomware attacks. And so the system alert window is an attempt to basically show you an alert that is persistent on your display and actually get your.
Kristina might have dropped. Again, thanks for listening, and you can DM either of us on Twitter with more questions, I guess. So thank you.